Thank you all for joining us today for a webinar, Powering IoT Integration Solutions, Turning Data from Sensors into Real-Time Actionable Insights. With 20.8 billion connected things expected to be in use worldwide by 2020, IoT offers huge potential for many industries, including manufacturing, transportation, healthcare, security, and more. Collecting and aggregating and analyzing this massive amount of data is imperative for enterprises looking to act on real-time insights. Today, we will be discussing GigaSpaces solutions for the industrial Internet of Things, as well as Magic Software's IoT integration solution in case study. We will learn exactly how the InsightEdge Platform powers Magic's IoT integration solutions and how GigaSpaces enables Magic's XPI's customers to simplify and accelerate telemetry ingestion, as well as to gain full business value from IoT adoption. We have with us today two speakers, VP of Products and Strategy at GigaSpaces, Ali Hodroj, as well as Yuval Lavi, VP of Technology and Innovation at Magic Software Enterprises. I'm Don Mischiani, the Marcom Manager here at GigaSpaces, and I'll be your moderator for the session. A few housekeeping items before we begin. It is important to note that this webinar is being recorded. The recording will be made available to you at the end of the webinar. Also, if you have any questions throughout the duration of the webinar, please check the bottom of your screen. There is a button for Q&A, and you can enter in your questions, and it will be answered in the order they're received at the end of the session when we get to our Q&A section. Without any further ado, I'm going to hand the floor over to Ali Hodroj from GigaSpaces. Ali, the floor is yours.
All right. Well, thank you, Donna. That was a great introduction and context setting. So I'm going to start by giving an overview of GigaSpaces, and we're going to follow through with demonstrating how in-memory computing plays a role within the Internet of Things, and specifically IoT analytics, followed by our guests from Magic Enterprises. A quick brief about GigaSpaces. So we are a software middleware company focused on high-performance in-memory computing solutions. And we started in the early 2000s, initially in financial services, moved on into healthcare, telecommunications, e-commerce, solving problems that have to do with low latency, high throughput, and horizontal scalability type of infrastructures. We serve a portfolio of about 300 customers, 40 of which are Fortune 500. And if you look at the list of our customers that use GigaSpaces, you'll notice the global who's who of Fortune 2000. And the common thing across all of these customers that we see, while they are diverse in terms of investment banks, telecommunication companies, retailers, and others, most of them are trying to be insight-driven. And by being insight-driven, the idea is that using analytics at every angle and at every corner within their application, not only as means of differentiation, but primarily as the lifeblood of their application and the way to compete and survive in the industry. So a few of the use cases that we see within our customers in the field are things around operational analytics. If you look at financial services, use cases that have to do with fraud detection, the type of data processing and data transformation, where you need to analyze data in the moment. You need to do correlations between real-time and historical data. We see that a lot also in e-commerce, but more from a predictive analytics perspective, with use cases like personalization, recommendation, and providing machine learning and data science capabilities for multi-channel type of commerce is a key enabler for customer experience and converging with the customer at every channel. So in addition to providing these analytics, the need here is also, as you know, in e-commerce, every e-commerce website, if it doesn't load within 3 seconds, you lose about 40% of your customers. So within that end-to-end 3-second latency across many different channels, you also need to converge with the customers and do this hyper analytics, if you will, to provide the right level of insight, as well as use that insight to trigger actions and workflows such as channel retargeting, recommendations, and others. Now, the interesting thing that we also see combining both types of analytics against data in motion, as well as predictive and proactive type of insights, are things around the Internet of Things, and specifically the industrial Internet of Things. We see that a lot in telecommunications, retail, railway, transportation, and other verticals. But primarily, it's the idea of ingesting data from the field, making sense of it, combining multiple data types or data endpoints from spatial to transactional data and others to be able to come up with a kind of data 360 type of platform that could identify patterns, that could identify certain areas for operational efficiency, and using that data in real time, or these results in real time, to, the second phase of IoT is not just sensors, but also actuators, taking that back to the field and triggering some actions or workflows within the sensors or edge components. So with every IoT type of engagement that we've been with, we know there's basically 4 key fundamental capabilities that the platform needs to provide. The first capability is having center-to-edge type of low-latency processing. The thing about IoT, in contrast with traditional architectures, is that while we've been focused, in big data and data processing platforms on high throughput type of workloads, IoT lends itself more to many low latency, low volume type of streams. And for these types of streams, or these kind of workloads, the focus is more on event-driven, reactive, low latency type of processing rather than high throughput data ingestion. Now, in addition to low latency processing, IoT data can come at many different intervals based on the protocol being used, the sensors, the network latency, whether some device or sensors is within the network or out of it. But the idea here basically is that you need to maintain some level of statefulness within the pipeline. And by maintaining statefulness, there's the need to converge both real-time and historical data together to be able to converge them and basically unlock insight off of some correlation between many disparate sources. Now, the dominant problem is in IoT is data, and the killer application is data analysis and control. So obviously, connecting insight to action is a key requirement that we see here as well. So as mentioned, first phase of IoT is getting data from sensors, but the second is, if I detect anomalies or patterns from, hundreds or thousands or millions of oscillations off of an engine, I need to be able to trigger some kind of workflow or action to stop that engine to prevent, a $1 million type of machinery from failing. And then finally, what we see also a departure from classical type of architectures, whereas we've been used to, layers and tiers in classical architectures, even in distributed computing type of applications. IoT, from the get-go, you're basically starting with converging the edge, the center, and possibly the cloud all together. And the data needs to flow between them in a decentralized fashion. So this is a departure from layers and tiers to more of graphs and topologies, where federating across many different data centers, clouds, and edge devices, as well as being able to have efficient data replication and data sync across all of those. So to us, the approach that we took for the Internet of Things was something that we've done from the beginning with transactional applications. And that approach is in-memory computing. In-memory computing is the idea of utilizing RAM, which is basically the fastest storage medium on machines, as the primary storage as well as business logic processing medium for any type of workflow, whether it's event-driven, whether it's batch or transactional type of applications. And the goal here is to put everything across many machines and utilize all of RAM as one collective in-memory data fabric. And that's where in addition to transactional capabilities, auto-healing, and horizontal scalability, you start building this middle tier that could basically connect the edge devices, sensors, and data coming from many different sources to real-time applications that are deployed on this scale-out type of architecture. We've been recognized through Forrester and others as a leader in this domain. And the flagship solution that implements in-memory computing for GigaSpaces is XAP, which is an in-memory data grid. XAP as an in-memory data grid essentially is a cluster of many machines which uses a Java-based technology platform. And essentially, we're federating many Java virtual machine containers all together as one large in-memory and application type of fabric. So in contrast with the analytics, in-memory analytics type of capabilities that you see with frameworks like Storm and others, this is more focused or implements capabilities that have to do with strong data consistency, with application type of workloads, whether it's event-driven or others. Also, since this was initially born in financial services and mission-critical use cases, high availability, multi-data center replication, resiliency, and auto-healing are foundational capabilities of this grid. So that core engine is what we took to be the foundational element of an IoT platform. At the very heart of it is the XAP in-memory data grid, in addition to three angles that you see on the screen here. The first one is what you see on the upper right-hand side, is implementing microservices, event-driven and low latency and extreme transaction processing type of workloads. The second is adding Spark natively on top of any transactional data that is flowing through this data grid. This is the analytics and machine learning angle. And the third is search and query to be able to do some kind of ad hoc reporting and BI type of capabilities. We embrace an open source ecosystem. So we've bet on Spark, we've bet on other frameworks as well. And that gave us the connectivity to upstream data tiers that have to do with the streaming, with messaging type of applications or message brokers like Apache, Kafka, and others. And if we drill down into what the deployment footprint looks like, or deployment model for a data grid in this case, the specific, the tiers that you see basically in a machine within the InsightEdge platform, where XAP is the core component, is basically the data grid container, which is all in memory. This is basically a very large kind of a JVM container or process. And right on top of that, you have Spark workers. So the combination of both of those, XAP data grid, as well as Apache Spark, is what we call the InsightEdge platform. And essentially, the idea here is to provide a unified transactional and analytical platform together that could be deployed at a regular or your traditional data center within a cloud, and at the edge components as well. So you can take basically the core data grid engine and basically deploy it within IoT gateways or IoT hubs, which is what we're going to show in the case study. Now, the benefits that we gain by combining these two worlds together of in-memory, distributed in-memory analytics or in-memory data processing with Apache Spark, along with in-memory data grids, which were built for extreme transaction processing and mission-critical applications, we get basically the full spectrum of analytics as well as transaction capabilities. On the data management side, everything from SQL capabilities to graph processing to POJO or graph type of applications, just your good old or regular web applications or microservices that use these as domain models or data transfer objects. In addition, while the data grid runs primarily in RAM, we've also tiered the storage across every node in the in-memory data grid to be tiered between RAM as well as SSD to expand the footprint. So for deployments where the data footprint is beyond a few terabytes, start making sense from a price performance ratio perspective to have the rest of the data basically stored in SSD or flash. We're also doing some work with Intel, integrating with Intel Optane SSDs, primarily what's based on 3D crosspoint technology. We see a blurring between the storage and memory technologies, and we've fused or converged both of those together into one horizontally scalable in-memory data processing, analytics, and transactions architecture. The data grid is a Java platform. It could be deployed on your data center, on the cloud, as well as on any type of commodity machines or specialized machines And at the orchestration tier of the data grid, you get the cloud native type of capabilities. So RESTful orchestration of any component without having to, build specific application using specific protocols to communicate with the data grid, containerization through Docker and others, as well as the ability to scale out and adding more nodes and expanding both, eliminating bottlenecks, at the disk, CPU, and other serialization and network I/O type of bottlenecks. The addition of Spark as well, being native to the data grid itself, gives us everything from the basic, analytics, reporting with SQL and others, as well as the advanced data science of machine learning, graph processing. Also, our integration with frameworks like Intel Big DL for deep learning, that opens the door for advanced use cases such as natural language processing and image recognition and others. Now, our play in open source and embracing this ecosystem gave us the capability of integrating the data grid with open source data processing components such as Kafka and Hadoop across many different architectures. So if you're looking at a streaming analytics data pipeline, we've simplified the big data architecture basically to be simply your classical Kappa architecture, which is Kafka, and then you have a data transformation tier, then a serving layer, then a reporting layer. All of that to be consolidated into simply two tiers, Kafka, and then the InsightEdge grid, which have Spark embedded in it. You have Spark streaming that connects directly to Kafka and ingests the data from there, as well as having the data grid being a transactional application server. You're able basically to deploy applications in place right where data is being processed. So essentially any data result or any data that is managed by transactional applications will automatically surface as RDDs, data frame, or Spark entities. And any result off of Spark analytics workloads, whether it's ETL or data processing or machine learning type of scoring workloads or workflows, that would be immediately available for transactional applications. So we're fusing both the analytical and transactional capabilities without having the need to do data processing or moving data between many systems. The same applies if we're looking into things like Lambda architecture, combining Spark, Hadoop, and the data grid, where Spark is the kind of speed layer, the data grid is the serving layer, and Hadoop basically serves as kind of the batch or historical layer. And then finally, with having different types of data modeling capabilities in the grid itself, operationalizing a data lake such as Hadoop, for example, this is something that you can utilize Spark as well as our text indexing capabilities to ad hoc ingestion of data from Hadoop or other unstructured data sources, and operationalize that and build applications or turn that data into services right on top of the of that data that's indexed in the grid. Now, what does the InsightEdge architecture look like in production once we start building these type of systems? So I'm going to talk about two reference architectures, which give basically the way for Magic to show the use case of using one of these design patterns. The first design pattern is basically what I call the Edge Hub Cloud architecture pattern, and that's basically where you have a 3 tiers basically in the system, where on the right-hand side you have the kind of a micro instances of the data grid deployed in gateways and in other systems at the edge. It could be used either for replicating data back to the hub or the center, or for use cases where we need to analyze data at the edge. Some analytics or processing can run directly against data that's being generated from these sensors or devices. The second tier is mostly for hub, for data transformation, acting basically as a data hub and a streaming pipeline. That's where the kind of data cleanup and others happen, and then finally replicated into the applications tier, which runs on the core data grid, which is XAP. The other architecture pattern that we also see in the field is a simpler pattern, but focused mostly on combining both the transactions and analytics under one data grid. So on the right-hand side of the screen, what you see is the combination of transactional applications, along with Spark, streaming, machine learning, and type of workloads. And there is asynchronous bidirectional replication of data and analytics results that happen between edge grids and the grid that's basically deployed in the center. So this is the way of converging the analytics of things at the center and the operations of things that are running at the edge. Now with this, I'll hand it off to Yuval from Magic to present how XAP and InsightEdge are being used within an IoT integration hub and data pipeline for automotive telematics.
Thanks, Ali. Thanks for the great presentation. Now, let's see that you can actually see my screen. And I'll just share my desktop since we are going to also see some live demo, hopefully, if God of demo will allow it. Okay, good. So let's talk a little bit about what is integration in the IoT. Just a few words about us, Magic. Magic is quite an experienced company, 35 years in the market. We are listed in the NASDAQ and in the Tel Aviv Stock Exchange. We are located in over 50 countries. We finished last year with over $200 million in revenue. We are over 1,700 employees, and we are still growing. We are working directly with enterprise or SMBs, and we have our partners channel that we are working with, and we are doing business in the application platform and the integration platform. Our focus in the last few years is really taking integration to the next level. So as I mentioned, we are all over the globe. Some places we have our own subsidiaries. In some countries we have distributors. We are a low-code or a no-code platform, okay, that provide a robust solution. We started 35 years ago with the concept of how to develop application without doing low-level coding, and we moved to the integration, again, what Gartner referred to as a citizen integration, but still a robust solution that can integrate on any scale. We provide end-to-end integration solution to our customer, either just the tool or really also project management, either directly with our own internal team or with our partners around the globe. We're making sure that we're an easy to use, really fit for SMBs, but we still feel very, very comfortable in the enterprise market. We have customers from all different levels. I guess asking again the question, why Internet of Things should matter? I think Ali mentioned it a little bit, Dana mentioned it. I'll mention it again with this slide. This is what we expect in 2020. 4 billion connected people, 4 trillion revenue opportunity, and the numbers just keep on growing. So yeah, IoT is going to be a huge impact on our life. If we thought that the internet actually made the difference in our life, IoT will make a bigger difference and will be much more dramatic changes. We know that IoT already is looking into be implemented, for instance, in vehicles. The Los Angeles Highway Patrol already approved vehicle-to-vehicle communication. If you think about it, makes sense. 2 machines can communicate much better than we human beings can. They should prevent accident, going to be much safer. But not only big things like cars or industry. When I was doing some research, I saw that there is actually a connected pot that is connected via IoT. Can know the sunlight, can know the water situation, if you need some more water, if you need some more something. This pot even has community, which me personally still don't have community. This pot has community. So things are moving fast into the Internet of Things. If we just look at the landscape of Internet of Things in 2016, it's huge. It's all around us. It's in every small and big place, coming from all different sides and all different angles. So, where is a Magic Integration Platform coming into the IoT? So we are more looking into the industrial environment. In Europe, where we call it Industry 4.0, or in the US, they call it the fourth industrial revolution. But at the end of the day, if you look at our world and what happened in the last revolution that is coming now with the what we call cyber physical system, actually the machine, the robots are going to be connected. And again, this is going to have a huge impact on our life. So if you're looking at the Magic end-to-end no-code integration platform, we have the option to connect to all different environment, all different legacy system database, from the latest NoSQL database to the oldest mainframe database. We have a standard connectors, certified connectors to all the legacy system like SAP, like Oracle JD Edwards, also cloud database like application like Salesforce. So we can connect to anything. Once we connected, we actually taking this information and doing some transformation with it, whatever it needed, either just ETL processes or implementing logic. Again, everything is without any code. If we do need to do some coding, we can actually jump into Java or .NET and code in that, but it's rarely there is the need to actually do coding with our tool. Once we did something with this data, we distribute it either back to the different system or to different databases or to different platforms. And if there is a call for it, we can actually present it in any format, on the desktop, on the mobile, on the browser, in any place that we actually need to present it. Now that was what we did in the last 12 years, basically. And now, as we all know, IoT is coming. So we added another wheel to this process, and we looked how to resolve it and what to do with it. And we found out that really the best thing is to actually implement it with our longtime partner, GigaSpaces, with their capabilities of the InsightEdge. If we're looking at our studio, as I mentioned, it's really, there is no place to write code. It's a Visual Studio solution that everything is working with drag and drop, pick and point and pick. And if you need to write something, it's a name of a flow or maybe a small expression, but really no place for coding. We have our great tool of data mapper that can look at one source and point it to another source, and everything will automatically be migrated with manipulation if you want in the process. But again, no coding is needed. So when we look at the integration or the connectivity on the enterprise from the devices, from the different industrial devices into the backend system, we actually need to connect this arrow all the way up. And we found that the best option will be to actually build what we call the IoT hub, which is based on Kafka as the broker, InsightEdge as the tool that actually orchestrates everything on the IoT hub, running Spark, and then connected to our integration platform, which is the Magic XPI that plays as the orchestration. Once we have the information there, we can actually push it into the prediction engine that we implement, into data lakes that are part that can be connected, into any desktop application or to a mobile application. The two important parts here is the data aggregation and the orchestration. Those are the two key features that we need to understand and look in when we come to this type of a solution of IoT integration. So for a use case that we actually needed to deliver, we had a scenario of 25,000 vehicles, okay, that was sending each second a message, okay, into the hub or into the integration platform. Now, if you look at the numbers, 25,000 vehicles every second. If we check just a snapshot of 15 minutes, that means 22.5 million records, okay, each 15 minutes. It's a huge amount of record, okay? And let me tell you, typically, it's not really relevant if we look at this amount of records, especially for vehicles. The speed didn't really much change in 15 minutes, the car temperature or anything. Of course, all data needs to be absorbed somewhere, but pushing it into the backend legacy system, those 22.5 million records is really not relevant. So what we did is actually we put the aggregation layer, and the aggregation layer should be as close as possible to the device itself, or the minute that you, or the millisecond that you observe the information, you want to start aggregating it. So if we aggregate the information, and for this example, for per 15 minutes, we create only one record, we actually are moving one, again, to 25,000 records each 15 minutes. It's 1 to 900, which we have 900 seconds in 15 minutes. That's easy math. But we can create a record of maximum, minimum, average value. And this information is actually the information that we use going forward. So if the God of demo will allow it, we'll actually try and see it's working in live. What we'll show in a live demo is actually taking the information into InsightEdge, aggregating the information, sending the relevant or the aggregated information from InsightEdge into a Magic XPI layer integration platform. We receive the data, we extract the relevant data that we know is relevant for the machine learning algorithm. We send it into the prediction engine. If the prediction engine will predict, again, it's not calculating, it's predicting that error is going to happen, it will go with the information to the asset management and ask about the information that was just sent. What is the equipment that there is in this location? With the predicted error and the equipment, it will go to the knowledge base and take all the information of how to fix this specific equipment. With that, it will go to the case system and open a service call for this specific device in this specific location with this specific error, with all the explanation of how to fix it. It will send to the mobile of the technician the predicted error with all the information that he needs to know in order to fix it. The technician will actually do the fixing and will submit the fix from his mobile device. And again, we're going to see everything in real life. So let's stream some data. And now let's share. Oh, no, I think you're sharing my desktop. Dana, please correct me if you don't see my screen. Okay. Can you see my screen now?
Now I can see your screen, yes.
Okay, perfect. Okay, so we have here our case system, which in this case it's Salesforce. And we see we have a few cases, some of them closed, some of them are open. Last one is 1208. And we also see our data grid, which is the InsightEdge management. Okay, that I see that I don't have any records in the car event. Now what we'll do is let's stream some data. Let's just run this one for a minute. And let's stream some data into our InsightEdge. So we basically threw in 1,800 and something records, and it's finished, and everything is inside the memory and inside the grid, which is, you have to admit, it's amazing, the speed that things are coming in, and those things are already what we call a real life objects. Okay, that means that it's not just streaming, it's data that I can look at, that I can investigate, that I can do whatever I want, and I can run manipulation on them. Now what we'll do is actually run the aggregation process that typically is running in parallel, but since it's a demo, we need to see it running. And now my system will go into this memory, IMDG in the memory data grid, calculate and check whatever needs to be checked and do the aggregation, and will actually stream it into the integration layer, and all the process of opening the case will happen. Now, let's see that we can actually see my mobile phone. Oops, okay, and I imagine that you can see my mobile phone. And now, in parallel, we'll open the mobile application. Well, cannot access the server, this is not nice. Let's do it again. This is the God of demo. It was working 5 minutes ago. Okay. Let's first see that the case is created. Oh. Okay, so we have the case, but unfortunately, the mobile application is not running. And what we can see here that happened is actually that the case with the relevant documentation, okay, which is the right instruction and everything, was just open, okay, bar process in our Magic XPI, and again, fortunately, demo did not work, and the server, the mobile application server, is not running. But going forward, what happened is actually streaming of good data, which is, this is the structure of good data, and don't ask me why, was actually absorbed by the system, and suddenly we saw some bad data coming. And again, this is all machine learning algorithm. In this case, it was a random forest algorithm or model that generate the error and created the case for me. Now, if we look at what happened, we got the information coming from the data hub, or coming from the devices into our data hub, absorbed it by Kafka and InsightEdge, run on the hub itself on the in-memory data grid calculation, and we can do it either by Java, by Python, or by Scala. And we send this information via a secured and compressed mechanism of, again, GigaSpace technology, which called One Gateway. And this is a mechanism that replicate information in one grid to the other grid. And this is the grid of the integration. And from that point, I can actually start playing and doing what I need in the integration layer. So if we look at the concept of deploying the solution, typically a basic integration solution, and this is, again, for a long time, our technology is running based on ZAP, the technology from GigaSpace, and you have different APIs that are calling our integration platform. And once we get it into the grid, we can actually run some logic process of the integration and connect to anything that we need to connect in the backend. When we wanted to add the IoT layer, what we did is added another space here using the InsightEdge. The things connect to the IoT hub. Here we do some basic logic, in that case for aggregation, and then we push it through a secure tunnel through the one gateway directly into the space of our integration platform, and from that point everything is continue working as it does all over the years in our integration platform. So if we look, the power of XPI integration is really connecting to the different system, to different places, either in cloud or on premise. And now with the new power of the IoT solution that we brought to the IoT hub, we can actually take any device, any messaging in any volume that we want and take it and push it all the way into the experience aggregation or integration orchestrator. Our focus in the IoT solution stack was, again, orchestration, data aggregation, performance must be in first place, and at the end of the day, we simplify the big data architecture. If until today we called big data, we talked about big data, but we didn't know what to do with it, now we have the design patterns of how to take big data streaming, collect it, and actually make it into sensible data that we can analyze, predict, train, do whatever we want with the big data, but actually make it matter. That was our use case. I do apologize that the mobile device there itself did not work to close the cycle, but I think the idea came through, or at least I hope.
Thank you very, very much, Yuval. Yes, indeed, you can't control the demo gods, but that was super insightful. So thank you again. And now, guys, before we move on to our Q&A section, I'd just like to quickly give you an overview of our webinars. We have a couple of interesting webinars coming up in August. On August 2nd, we'll be holding a webinar discussing from data to services at the speed of business. And the second webinar on August 23rd will be about machine learning and insight platforms. Both these webinars are part of our recent HTAP webinar series. And you can also find two of our recent recorded webinars. The first is real-time microservices from zero to production under 3 months. And the second one will be this webinar, which we'll put up on the link below at gigaspaces.com/webinars. All right, and now we'll head on to our Q&A section. Thank you again to Yuval and Ali. And a quick reminder to anyone who wants to ask a question, feel free to check at the bottom of your screen. There's a button for a Q&A, and you can enter in your questions. And of course, it will be anonymous. All right, guys, I see that we have a few questions in the pipeline already. The first one is addressed to Ali. Is InsightEdge open source?
Yeah, sure. Thank you, Donna. So InsightEdge is open source, and there is no limit on what API or type of workload you can run, both the analytics or the transactional one. There is also a premium closed source edition, which is basically focused on enterprise-ready or production-ready type of capabilities. So security, multi-data center application, auto-healing, instrumentation and monitoring type of components. But on the API front, everything is open source, and it's under Apache 2 license.
Okay, great. We have a question for Yuval. Yuval, what would be the key differences between standard IT integration and IoT integration?
Okay. What we did in the last, 10 years or more with a lot of, and when I say we, is all of us, the IT industry, when we're connecting integrations, between system, we actually integrated data or moving data application integration. That was the main thing. Our project could have worked for or be implemented through a year or even 2 years process, because that's considered to be the cycle of IT project. Nowadays, everything is much faster. We are living in the agile world. We need to work much faster, and integration in the IoT must be focused on, from my point of view, on ROI. That means that we need to actually show ROI within a few months to max a year of our project. That means that our project needs to be implemented very fast. And one thing for sure is that things will change. Things will change all the time. We'll connect to this device and tomorrow to that device. Today is this message, tomorrow is another message. So we need to decouple our process from the first layer of that is actually consuming or observing all the messages, and from the logic of calculating and analyzing and implementing our business. So the decouple or the good architecture is the key point in IoT integration, is really to do good separation of concerns. And I think what we did here with the tool of InsightEdge is actually showing it, that one thing is the device and the first layer of aggregation, and then we take it into our old way of doing things and pushing it back to the legacy system.
Okay, great. We actually have a few more questions. This one, how is the security done in the solution, and how will you connect to hundreds of machines at different customers?
I think, again, Ali can put maybe more detail about the different level of security in the one gateway. But from what we do is we actually put a specific hub per customer. It's not one hub that observes everything. We put different nodes or different hubs per customer, so it's like it's totally decoupled. It's totally segregated. They are not sharing the same space. And since the solution is flexible and we can actually scale up, scale side very easily, we don't need to share resources between or to share spaces. We can share resources, but we don't need to share spaces between different customer, and each space is per customer.
Yeah, and thanks, Yuval. And just to touch on how to connect a lot of endpoints, thousands of endpoints, if you will, to the platform. At the core data grid, InsightEdge and XAP level, there's a couple of approaches. So one, the data replication that happens across different domains, the edge, the center, the cloud, is asynchronous in-memory replication. So you're not incurring any types of locking or synchronization that could impact throughput and latency. Now, as a core capability of the data grid, what we introduced is, as Yuval mentioned, the WAN gateway. WAN gateway lets you build many different types of topologies. Either it could be, a hub and spoke, could be a ring topology. It's really based on two patterns of delegating data to some other grid or receiving data from another. And the arbitrary combination of these delegators and sinks are basically our approach to create many different topologies for connecting devices. Now, this is basically if you're decentralizing the connectivity across many, and all of it are, the talking back and forth of data grid. Another approach is either using a hub, or you can use basically, since we're the upstream ingestion tiers, they could use Spark streaming. We could do something with Apache Kafka, used basically as a centralized message broker, and you basically scale that horizontally across, as you add more producers to the system. Now, the reason why we pick Kafka sometimes is because the data grid is horizontally scalable. You have data locality between the Spark worker and the data grid partition or container, which also gives us data locality all the way up to the Kafka level by broker or topic. So we're able to scale linearly by adding more producers and across the 3 tiers, from Kafka to Spark to the in-memory storage or serving layer with InsightEdge.
All right, thank you guys. Lee, there's another question here for you. What is the typical deployment footprint for a data grid?
Yeah, so that's the common answer is it depends, but typically you would expect this is all running in memory, right? And if the data footprint practically fits in RAM, we see an average basically between 1 terabyte and 3 terabytes of RAM only capacity. But we also have customers that went on to basically double-digit terabyte footprint, all the way up to around 80 terabytes. And at that point, we converge both RAM, primarily the JVM heap, along with SSD or flash devices. So you'd expect basically between a couple of terabytes to around 80 or so.
All right, thank you. Moving on to the next question. Yuval, is IoT integration projects, are they complicated?
Oh, that's an interesting
A simple question with a complex answer.
How much is a house? But at the end of the day, I think if we keep the focus of what needs to be done and step away from the how to implement it in the technology way, we can simplify the project. Again, an IoT project contains a lot of different layers in the solution. But the complicated part should really stay to the machine learning and the data science part, and observing the data, taking the data, running it to the different devices, collecting it to the different ecosystem. That shouldn't be complicated, and this can be done very easily with the tools like Magic XPI integration. The data science part itself, it can be simple, it can be complicated. That's already depend on the use case and what we're trying to do with the information. But just taking the data from the devices, pushing it into the space or to a place where we can actually do something with the information, and moving it forward to the backend system shouldn't be complicated. That can be quite easy.
All right, Yuval, one last question for you. Is Magic providing only the tools or also the technical resources if needed?
Okay, so as I mentioned in my presentation, we are a vendor company all over the years, but we do have a lot of professional services, and we help our customer all over the world in implementing project. And actually, we are also offering now what we call the managed service, that we can take the full headache of the implementation of the integration from the shoulder of the customer, and do the project itself, the running of the project, the maintaining of the project, upgrade it if necessary, 24/7 support, all things around that we do provide today. As far as data science, we are working with partners to actually bring the best people that are relevant for every industry with data science in order to build the machine learning part of the solutions, or we are working with the customer existing team in order to implement it. So no, we're not only bringing the tools, we are bringing, as I mentioned, end-to-end solution, and we are bringing our 15 years of integration experience from the field into our customers.
Indeed. All right, final question. This one's for Ali. How do you compare to in-memory databases like SAP HANA?
Yeah, another common question. So typically the in-memory computing world, you have in-memory databases, which you're used to, and you have in-memory data grids. The difference is in in-memory database like SAP HANA, mainly these are drop-in replacements within your application stack. These are relational databases You can use your existing, SQL and relational type of workloads or data modeling directly on those, and they utilize some kind of, interesting storage engines or query engines to be able to tier between disk and memory. Now, an in-memory data grid is a distributed scale-out type of data storage and business logic processing platform. The way it differs is that it's not a replacement for a database. It actually sits at a tier or a layer above databases or data sources. So the main difference is that, while an in-memory database is meant to be a replacement for existing databases, data grids are meant to join many data sources into one in-memory data fabric. Now, it's also worth mentioning that with everything becoming in memory and the price of RAM decreasing, a lot of these platforms are overlapping in use cases. For example, we are implementing SQL type of capabilities in our data grid as well. But primarily, that's the difference: is drop-in replacement or an integration tier.
All right, guys, our hour is nearly up. I'd like to thank Yuval and Ali. Thank you very much for your super interesting presentations. And I'd like to thank everyone who asked a question. And again, quick reminder that we do have more webinars coming up, and you're welcome to register at gigaspaces.com/webinars. Thank you all again for joining us for a webinar powering IoT integration solutions, turning data from sensors into real-time actionable insights. We appreciate your time. We hope you enjoyed it. And for those of you who are listening in or watching this at home, please feel free to reach out to us with any questions you may have. And the recording, as promised, will be made available to you soon. So thank you for joining us, and we look forward to being in touch in the future. Take care, everyone.